Hi to you watching this video. So we are still on module number 3, but we are already on unit number 9, vertical stress caused by a rectangular loaded area. So for example, this is your rectangular loaded area. We are interested in determining the vertical stresses caused at this soil mass here. Now, the increase in the stress at point A caused by the entire loaded area is given as delta sigma z is equivalent to Q times I3, where I3 is equivalent to this equation here, where M is equivalent to B over Z and L is equivalent to L over C. B and L can be interchangeable in this equation. So, pwede silang pagpalitin. Okay? So, with the variation of I3 with M and N is shown in table 3.9. So, again, for this case, we can have two solutions. We can use the equation and we can use the table. So, the term of arctan must be converted to radians. So, for this, for the equation method, arctangent here must again be equivalent to radian. Now, if the value of the arctan is negative, then we simply add pi. So, we need to solve this first. Pag lalabas yung negative, then we add pi to make it positive. Now, if we're going to use the table, then we will be having here the value of n and the value of n. So, vertical, horizontal. So, kung saan magmi-meet yung dalawang value. Now, again, if the value is not present here in the table, we should use our equation so as to reduce errors due to interpolation. Okay, so let's have here an example. So refer to figure 3.58. This is our 3.58. A flexible rectangular area is subjected to a uniformly distributed load of 225 kilopascals. Determine the increase in vertical stress at depth of 3 meter under point load. By the way, this equation here or this formula here is only applicable for loads which are located at the edge, okay, at the edge or at the point of our uniformly distributed rectangular load. Okay? So, pag nandun siya sa gitna, then gagawa natin ng paraan. Pero itong formula na to is only applicable if the load is located at the corner or at the edge of our load. Okay? So, here, determine the increased vertical stress at depth of 3 meters under point A. So, point A here is at the edge. So, wala tayong problema. We can proceed right away. So, our given are Q, 225 kilopascals, Z is 3 meters, B is 3 meters, L is also 6 meters. So, we need to determine delta sigma Z at A. So, first, we need to determine M and we need to determine L. So, by the way, any value can be M, any side can be L, any side can be L. But para hindi tayo malito, let's try to have a convention where L will be the longest side. Okay? So B here is equivalent to 3 meters divided by the Z of 3 meters. So that is equivalent to 1. Okay? Next, for the N, we have the L. L here is 6 meters and Z here is 3 meters. Therefore, that is equivalent to 2. Now, using the equation, this will be our working equation for I3. Okay? So, in this case, pwede magbali-baliktad din si M at saka si N. Kasi kung titignan nyo, parehas na meron tayong M and N and they have the same power on every term. Okay? So, input natin our M. M here is equivalent to 1 and N is equivalent to 2. So, we have 1, substitute 1. We have 2. Then, M is 1 squared. N is 1 squared. No. It's not 1. It is 2 squared. Divided by, we have M, which is 1. N is equivalent to 2 squared. Then m, we have 1 squared times 2 squared plus the term here, m is 1, n is 2. Then same at the denominator, we have m1 plus 2 squared plus 1. Okay? Plus the second term, we have tangent times m, which is 1 times n. Then we have 1 squared, we have 2 squared. Don't confuse here, ang constant natin dito is 2, ang constant naman natin sa denominator is 1. Okay? So here we have 1 squared plus 2 squared minus 1 squared times 2 squared plus 1. In that, itong first term, this first term here is equivalent to 1.143. Then the second term here, hindi naman siya lumabas as negative, that is equivalent to 1.369. So, get the sum, multiply it by 1 over 4 pi, that is equivalent to 0.1999. Then, our equation is for delta sigma z at A is equivalent to Q times I3, where our Q is given as 225 kilopascals. So we have 225 kilopascals times 0.119 is equivalent to 44.977 kilopascals. Now what if we are going to use our table? So m is 1, n is 2. Okay. So lagpas na tayo dito sa m value na 1. So balik tayo dito. Okay. So m, we have 1, n is 2. So this is 2 coinciding with 1, parehas, 0.1999. So definitely it will give us the same answer. So 0.1999, so 225 kilopascals times 0.1999, that is equivalent to 44.977 kilopascals. Okay, next let's have problem number 2 here. So refer to figure 3.59. A flexible rectangular area is subjected to a uniformly distributed load. Q is equivalent to 225 kilopascals. So determine the increase in vertical stress at a depth of 3 meters under point B. So this is point B. Now the problem here is, ang sabi natin, our working equation, even even this for the table only works if the load is located at the edge or at the corner of a rectangular and uniformly distributed load. So what we will do here is we're going to divide this 6 by 3 meters into 4 parts in such a way that these 4 rectangles will have a point B on their edge. Okay, so as to satisfy our criteria for using the equation in the equation method in the method using the table. So we have here 1, 2, 3, 4, and if as you can see here, point B is already at the edge of each and every square. Okay, so delta sigma B or the delta sigma Z at B will now be the summation of the individual delta sigma contributed by these 4 rectangles. Okay, so that would be delta sigma Z at B is equivalent to Q times I3 1 plus I3 of quadrant 2, I3 of quadrant 3, and plus I3 of quadrant 4. So that all in all, it is a summation of all the quadrants. Okay, so for this problem, if the values of m and n fits the table, then it is easier to use the table because we will no longer be inputting the long equation, no, or input values in our long equation. But I repeat, if the values cannot be found on the table, then we use the equation. Okay, yeah. So first, let's consider this not quadrant, this rectangle 1. So we have by the way, quadrant 1 can be interchangeable. Not interchangeable. L and B can be interchangeable, okay, in this case. But like what we have said, let's use the longer side as L and the shorter side as B. Okay, so L is equivalent to 3.6 divide no so we have here 3.6 divided by the z of 3. Okay, and that is equivalent to 1.2. Next, napunta doon. Next, we have, for the n, we have 1.8 divided by 3. Tama ba? Our depth here is 3. Yeah, 3. Okay, so that is equivalent to 0.6. It's not 1.2. Okay, now using the table, let's find 1.2 and 0.6. And we have here 1.2 for m. Ayun. Then we have 0.6, 1, 2, 3, 4, 5, 6. So, nasa pang 6 siya. Okay. So, 1.2, 1, 2, 3, 4, 5, 6. 0.1431. So, 0.1431. Next. Ayun yung value natin. Okay. Next, for the rectangular area of number 2, we have 2.4 for the b over z divided by 3. So, sabayan nyo ako sa calculator. Alpha x divided by 3. Calculate. We have alpha x here is 2.4. So, that is 0.8. Next, we have L over baliktad. Anyways, parehas lang naman yan. Next, we have here L. Sige. Napagbaliktad natin. Sige, sundin natin. Actually, katulad ng sabi ko sa inyo, kahit pagbaliktarin natin, it will still have, or it will still generate us the same answer. So, what if, kunyari, instead of B, 1.8, 0.6 at saka 1.2. Si M yung 0.6. So, tignan natin. If M is 0.6, then N is 1.2. Parehas lang. 0.6 at saka 1.2. 0.1431. So, there is no issue here kahit magkabaliktad sila. But, let's follow the equation. Okay? So, we have here B is equivalent to 1.8 divided by 2.4. So, 2.4 divided by 3, ilan yan? 0.8. Ito yung 0.8. Eh, yung 1.8 naman is equivalent to 0.6. So, 0.6 and 0.8. Tignan natin sa table natin. 0.6 yung M and 0.8. So, 0.6 and 0.8 ito. Okay, so we have 0.1247. 0.1247. Okay, next we have the third area. So we have 3.6 L. We have 3.6 divided by the Z of 3. Then dito naman, yung B natin is 1.2 divided by 3. Okay, calculate. We have 1.2 0.4. Then next is 3.6. We have 1.2. Okay. Tapos, 0.4, 1.2. Balik tayo sa table. M here is 0.2, 1.4. Ayan, 0.2. Then 1.4 is this. So we have 0.589. So we have, ay mali, 0.4 pala. Mali. It's 0.4, 1.2. Oops. Ayun, 0.4, 1.2. Ito, 1063. So we have 1063. So I3 is 1063. Now for the rectangular area, this one naman is we have L as 2.4 divided by 3. Then B here is 1.2. Okay. Pag 1.2, it is 0.4. Tapos, 2.4 is 0.8. Tingnan natin. So, we have M is 0.4, then 0.8. So, balik tayo sa table. 0.4, 0.8. So, ito siya. So, we have 0.931. Okay? So, since we already have 0.931, since we already have the I3 of the four rectangles, then we get the sum, then multiply it by the pressure. So, we have here, yung 1 natin is 1431. 0. Plus, we have I2. I3 of the second, 1247. Next, we have I of the third. We have 0.1063. And lastly, we have 0.931. Okay. Then, we multiply it by our pressure. Our pressure is given as 225 kilopascals. Mali. So, we have here 225 kilopascals. Now, 225 times, we have 0.1431 plus 0.1247 plus 0.1063 plus 0.0931. That is equivalent to 105. 105.12 kilopascals. So that this will be the value of our delta sigma Z at B. Okay. Next is what if the load or the stress that we are trying to determine is outside the rectangular area for the uniformly distributed load. So what we're going to do here is we're going to try to find a solution in such a way that we are going to fit with our criteria that the load should be at the edge of the or at the corner of the rectangle. So, ang mangyayari niyan, we are going to introduce here a dummy. Okay? So, referring to figure 3.65, a flexible rectangular area is subjected to a uniformly distributed load of 225 kPa. Determine the increase in vertical stress at depth of Z, which is equivalent to 3 meters, under point C. So these are the given Q, we have Z, and we need to determine delta sigma Z at point C. So, yeah. So, to satisfy the criteria, apply dummy or imaginary load. I repeat, we are going to apply dummy or imaginary load extension as shown. So, here, it is equivalent to the big rectangle minus the rectangle of the small, or the imaginary rather. Okay? So, kung kanina, it is the summation of all. Ngayon, dito, ay ganun pa rin naman. But we need to take into consideration that imaginary or dummy load are negative because they are non-existing. Okay? So, we just add them and we need to subtract them. Okay? So, therefore, the increase in stress at point C is equivalent to delta sigma Z at C is equivalent to Qi of the extended minus Qi of the imaginary. So, that is equivalent to Q times quantity I extended minus I of the imaginary. Now, to solve for the M and N, we have here the M. So, ang L natin is, we have B over Z. Ang pipili natin dito, let's say, we have 7 point, for the B, we have, wait, what, ano ba yung, 3. B is 3 at a depth of, we have 3. 3 is to 3. Where's that? Ayan. 3 is to 3. That is equivalent to 1. Next, for the N, our L here is equivalent to 7.8. So, 7.8 divided by 3 is equivalent to sabayan nyo ako sa calculator. So that is equivalent to 2.6. Now let's check whether it is available or it's not available from our table or in our table. So dito sa table natin 2 at saka 2.5. Therefore, or at 2.5 and 3. So we have an increment of 0.5. Therefore, we do not have the value for M and N. So, given the situation, what we're going to do is to use our formula. I repeat, we will be using our formula instead of interpolating. That is to avoid errors due to interpolation. So, we have here our working equation for the extended. So, ang M natin is 1, ang N natin is 2.6. So, we have 1, tapos 2.6, then we have 1, we have okay. So that's not 1 there. So dito 1. (2.6). Then we have 1 squared, 2.6 squared. Then for the denominator, we have 1. Then we have 2.6. Again, we have 1 here. We have 2.6. Tapos 1. Then we have 2.6 plus 1. Then for the arctangent, we have here 2 times M times N. 2 times 1 times 2.6 times the square root of 1 squared plus 2.6 squared divided by 1 squared plus 2.6 squared minus we have 1 squared times 2.6 squared. Okay? Hindi tayo malito. Yan. So, simplify. Simplify muna natin yung term sa loob ng parenthesis. So, first term, second term. So, the first term is 1.105. The second term, the arctangent, is 1.442. Take note, this should be in radian. And if pag negative siya, we are going to add pi. But in this case, hindi naman. So, add, then multiply by 1 over 4 pi. Therefore, the I of I3 of extended, so yung buong mahaba is 0.20026. Now, nasatisfy natin yung condition. So, considering na yung extended natin, nasa edge niya na yung C. Now, pag isusubtract naman natin si imaginary, ang i-consider na lang natin would be the loading of the imaginary. Okay? So, since we already use the equation, idiretsoy na natin. But, it is available because 3 divided by 3 is 1. 1.8 divided by 3 is 0.6. So, available siya sa table natin. But since na-diretso na natin equation, let's continue with the equation. Pero, I repeat, pwede nyo gamitin yung table. Okay? Parehas lang. It's already your discretion. So, we have 1, 0.6. Tapos, we have 1. We have 0.6. Tapos, sa denominator dito, we have 1 squared, 0.6 squared, divided by 1 squared, divided by 0.6 squared, plus 1 squared times 0.6 squared. Okay? So, ganun lang. So, 1 squared, then 0.6 squared, then we have 2 times 1 times 0.6 0 no, not 0, 1 plus 2 points no, not 2.6, 0.6 squared. Then we have here 1, oops, we have 1, and we have 0.6, tapos 1, we have 0.6. Okay, and the value is equivalent to 1 over 4 pi plus the first term is equivalent to 0.965 plus the second term here, so this is our second term with the arctangent, is equivalent to 0.745. Okay, so add this times 1 over 4 pi is equivalent to 0.1361. Okay. Next, if we are going to check it sa table, we have 1 by 0.6, it is available. So, M is 1, then 0.6. So, dito si 1, tapos 0.6. It is 0.1361. So, they are the same. So, we can now proceed in determining this delta sigma Z. Okay. So, if we are to compare it, they are the same. 1361. Okay. So, we can now compute for our Q. Not Q. Delta sigma Z. So, Q is equivalent to 225 kilopascals times, is it 225? Yes. Times the first or the extended. The extended is equivalent to, what is the I3? 0.2026. Okay. Then, minus this 0.1361, and that is equivalent to 14.9625 kilopascals. And that is the delta sigma z at point C. Okay, now if you're going to observe, pag nasa loob, mas malaki yung distribute na stress or malako-contribute na stress doon sa soil mass natin. Pero habang palayo siya ng palayo sa soil mass natin, like for example, sa load natin, like for example dito sa labas, mas malaki yung value ng delta sigma z at point B compared where when it was in point C, and lalo na nung nandito na siya sa labas. Okay, so kanina 'di ba sa B we were able to get the value of 105 kilopascals, and nung nasa edge naman tayo kanina, yung first example natin, it was at point A rather, it is 44. Then, nung lumayo na siya, nasa labas na siya nung rectangle natin at point C, we were only able to solve for the value which is equivalent to 14. So, habang palayo ng palayo, paliit ng paliit yung delta sigma Z. Next, what if we are to determine the delta sigma Z at the center of the rectangular loaded area? So if that would be the case, that is vertical stress below the center of a rectangular loaded area, and delta sigma Z will be given by Q times I sub 4. Okay, so this is the equation of I sub 4. Okay, and arc sign here, I repeat, should be in radian mode, and M1 and M sub 1 and N sub 1 cannot interchange. The value of L and Z cannot interchange. And again, like the other problems, we can have two solutions here. We have the equation, or we can have the aid of table 3.10. So we have here the variation of table 3.10. So we have the value of M and we have the value of N. Now what we need to take note is the term in arc sign must be converted to radians. Then the sample points must be below the center of the area. Now, this equation can only be used if the sample that we are trying to determine, the delta sigma Z, is below the center of the rectangular load, or rectangular load. And B is the shorter side and L is the longer side. If the values of M and 1 cannot be found in the table, then it is better to use the equation so as to avoid possible errors due to interpolation. Now we have here an example, so same example, but we are going to determine at the center. So a flexible rectangular area is subjected to a uniform distributed load of Q, which is equivalent to 225 kilopascals. Determine the increase in vertical stress at the center of a depth of Z is equivalent to 3 meters. So we have here Q 225, Z is 3 meters, B is 3 meters, L is 6 meters. Delta sigma Z is at the center. So ang L natin is the longer side, which is equivalent to 6 meters. Ang Z natin is 3. So 6 divided by 3, that is 2. Next, we have the N. So for the N, it is 2Z divided by the base. So what is Z here? We have 3 divided by the base of 3. Therefore, again, that is equivalent to 2. Now, using equation, since this is our working equation for I sub 4, input lang natin yung value natin na M sub 1 and N sub 2, which is 2 and 2, respectively. So, input natin 2 over pi. Take note ha, iba yung equation natin dito. It's 2 over pi. It is not equivalent to 1 over 4 pi. Okay? Yan. So, be very careful. And, yan. So, substitute natin. And this will be our equation now. So, this is the first term. Simplify muna natin yung first term natin. And that is equivalent to 0.433. Then, for the arc sign or the second term, that is equivalent to 0.3 to 2. So get the summation of these two values and multiply it by 2 over pi. And that is equivalent to 0.4. Delta Z at the center is equivalent to 225 kilopascals times 0.481. Okay? And that is equivalent to 108.225 kilopascals. Now, using the table 3.10, M sub 1 and N sub 2 is equivalent to 2. So, check natin. So, we have M, which is 2, N is equivalent to 2. So, ito, 0.481. So, substitute or place the value of C, or I sub 4 rather. So, 0.481. So, the same, no? 225 kilopascals times 0.481. And it will generate as 10.225 kilopascals.